Hello, this is Dr. Mears. Today we are going to be doing an introduction to sets. So please grab the document, unless I pass it out to you, and let's go. Basic set theory. A set is simply a collection of objects. The objects are called the elements of this set. There's set notation, which are symbols that are used to represent sets. We have capital letters that represent sets, lowercase letters represent the elements, and then we can use set builder notation to describe the properties of the elements. So you're going to hear me talk about sets and the elements within the set and the outcomes. So there's a little vocabulary here that you're going to have to get used to. You have seen this before. You actually have seen this before last year in Math Studies 1, so I am going to review it a little bit and then go from there. So let's first get down the symbols. So we have the set of integers. So integers are whole numbers and their opposites, such as -3, -2, -1, 0, 1, 2, 3. And we represent that by making this fancy little z. Then we have the set of positive integers, and those are 1, 2, 3, and we represent it with the little z and the plus. If we wanted to do negative integers, you're absolutely right, it would be z with a little minus, and that would be the negative ones. Then we have a set of natural numbers. Natural numbers are those numbers that you start learning in kindergarten, 0, 1, 2, 3, so on and so forth. We denote that by the letter n. Then we have rational numbers, which are going to be your fractions, and rational numbers are going to take the letter Q. Now, it's not the letter R because the letter R is going to be the set of real numbers. So that's this fancy little R that you've seen as real numbers. Now, there are those called imaginary numbers, and imaginary numbers are denoted by the letter I, a fancy I. However, I didn't write it here. I'm having you fill it in because we are not going to be talking about imaginary numbers in this course. So I just want to fill it in so that you know there are real numbers and there are imaginary numbers. Okay, there are several ways to describe which objects belong to a set. And so you're going to see me write this throughout the whole entire unit. I'm going to use capital letter here, the capital letter A. So we're going to talk about set A. And in set A, we can put some elements. We could do 1, 2, 3. And so these are the elements that belong inside set A. Please try the best with the little squiggly brackets here. You can practice them if you want. I'm not going to mark off if they're not perfect. Okay, let's look at another set. Let's set B. So set B, we can do 4, 5, 6, 7, and so we can carry on that set. There we go. We can even write a set in words. So if we're looking at set C, we can do names of people out of dress code. And bracket. So if we were looking for the names of people out of dress code, why don't you guys kind of take a look around the room and see who's out of dress code, and those would be the elements within your set, those names of the people that are out of dress code right now. You can also use set builder notation. So set builder notation is going to look a little bit complicated, but it's not. I am going to hold you responsible for being able to read set builder notation. So first, let's carrying on with the letter. So next letter is D equals our bracket X such that X is going to be in between 1 and 3. And you know what we could do? Actually, I'm just going to close these. Okay, let's just look at that set builder notation. This is just your variable that you're dealing with, X. This line right here means such that. And then X is 1 is less than or equal to X, which is less than or equal to 3. Now you've seen inequality notation before, so this should not be new. So you should know with this equal sign here, X can be 1, or it can be 2, or it can be 3. So the elements inside set D would be the numbers 1, 2, and 3. So that's what that's the elements inside D. Now here's the thing. You could include fractions. So there are going to be more, I'm going to add to the set builder notation. I didn't want to overwhelm you. Because how about 2.5? 2.5 is in between 1 and 3. So let's say that I'm going to stick with positive integers. So I'm going to put X are in the elements, and that's a fancy little E for elements. And let's do positive integers, so little fancy z plus. And then I close my bracket. So now I know that I'm looking at positive integers. Positive integers. Let's look at one more set builder notation, and I'm just going to flip this paper over, and you're going to see, I'm not writing here yet, I am going to do an example. So number one, let's do another example. So let's do E. And what I'm going to do is I'm going to look at a pair of numbers, and that's what this XY is, such that when you take the two numbers, you're going to add them up, and they're going to equal 5. Now, let X and Y, actually, you know what? Let's just leave it like that. I'm not going to go too far. So now what you have to do is you have to think of two numbers or a pair of numbers such that when you add them together, they equal 5. So let's think of some numbers. So let's see. We have 1 and 4, 2 and 3, -1 and 6. And you can go on and on. However, I am going to stop there. So I just wanted you to realize that we could have these two numbers and they could tell us to do something so that they equal 5. So you have to learn how to read these, and that comes through a little bit of practice, which you can have in your DCCs. Okay, now let's go back to number of elements in set A is denoted by n in set A. So what does this mean? I'm going to write down what that actually means. Okay, so this is the number of elements. And this is the set that I'm talking about. So the number of elements in set A. So let's go back to set A because we have a set A. And let's look for set A. Okay, set A is right here. Remember we have these three numbers. The numbers are 1, 2, and 3. We have 3 numbers. So that's how many elements are in set A. So let's write equals 3. There we go. So you have to know the difference between when we're talking about what elements are in A and when we're talking about how many elements are in A. So this denotes this capital letter. This is just what elements and this is how many. So how many here. And this is what. What is in set A and then how many. Let's look at another one. Let's look at set, let's see, the number of elements. Let's do in set B. So if you look back on the other page, you're going to see that there's 4 elements in set B. So I'm sorry, no brackets necessary. I'm just bracketing all day here. So let's write 4. Perfect. So the number of elements in set B are 4. And if you counted, the elements are 4, 5, 6, 7, and there's 4 of them. Okay, so just be careful so that you know this means the number of elements. What happens if I did something like this? The number of elements in set F. Now, I don't have a set F, do I? So let me write down what set F is. Set F is this. What do you notice? There's nothing there. There's nothing there. So the number of elements in set F is 0 because there's nothing there. Now, if you want to tell me what elements it is, you can either write it with the brackets or you can write it with a little line and a 0. So remember, F denotes the elements. N of F denotes how many. So the number of elements in set F is 0 because there are none. And you can also write it like this, and this is called an empty set. Okay, and there's nothing there. Okay, so let's move on. Let's go to a couple of the examples that I want to show you. So there's going to be 2 more examples. So this is number 2, so 3 altogether. So example number 2, I want you to do 2 things, and you're going to see this is exactly like your DCCs. The first thing that I'm going to want you to do, I'm going to want you to list the elements. And then the second thing, I want you to state the number of elements that you have. Okay, so let's do it. So we have set M, X such that 2 is less than or equal to X, which is less than 5, and our elements are going to be, you guessed it, integers. Okay, so what we have to do is first list the elements that are going to be in that set. Okay, so let's do part A. So inside, we see that X is between 2 and 5. We have this equal sign here, so that means it could be 2, 3, 4. Now let's look. It has to be less than 5, but there's no equal sign. So I'm not going to write down 5 because it can't be 5. All right, so that was part A, what elements are there. And part B, the number of elements of set M. This is how we write it. You're going to see me writing it like this. When we get into probability, this is going to change to letter B. So the number of elements in set M, let's count 1, 2, 3, there's 3. And so that's how you list the elements and state the number. So it's really reading what you have, reading set builder notation that you're responsible for. Okay, and the last example for today, that will end our video. I'm going to give you 3 sets. I'm going to give you set A. Whoops, that's a fancy. That wasn't a perfect squiggly. In set A are the numbers 1, 2, 3, 4, 5, and 6. I'm going to give you set B. In set B, we have 2, 4, 6, 8. And then I'm going to give you set C. 1, oops, let's do 3, 5, and 7. 3, 5, and 7. Okay, so here's your question. List the elements and you are going to have X such that X is greater than 3 and X are going to be elements in set A. So you have to look where set A is. This is the only one we're looking at right now because it just says set A. We have to list the elements. Let's see what it wants us to list. It wants us to list that X is going to be greater than 3. So let's list those elements that are greater than 3. There's no equal sign here, so I cannot include 3. So my elements are 4, 5, and 6. And that's it. That's how you do that. So this has been your introduction to sets, basic set theory. You learned some notation, you learned symbols, set notation. Hopefully this helped. Please, you may now go on to do your DCCs for practice. Thank you.